software development with Apache Cassandra, as it says on the tin. About me, I've worked for a company called last Pickle, clients to learn improve Cassandra-based solutions based in New Zealand, USA. I myself have been a Cassandra user since 2009. Version 04. Version 03 had a deep bug with deep table. So, a quick overview about what makes a successful software development project. And this is, in a general sense, is that it ships, right? It's maintainable, has good test coverage, and it's a single process to check out the build. And unfortunately, something like Cassandra, there's an impedance mismatch because this is an inherently distributed system, and you're running on a development laptop or a workstation. So there are just some things that don't line up like you would expect. There's failure scenarios in the test, and there's situations you can think about that you just wouldn't have to consider in traditional development process. We're going to walk through what some of those are and talk about them in detail. Of course, this presentation, this is an hour long. Some of these other ones have been 30 minutes long, so we can segue into stuff. If you see something that's interesting, ask me. I have a whiteboard. I know how to drive it. I'm happy to sort of document whatever you guys want to see. So we can just dive into stuff as it comes up. So first thing with any sort of Cassandra project to think about is, I was talking to somebody at lunch about this, is that when you're starting the project, you want to write your data how you're going to read it. And that was a fundamental truth 5, 6 years ago, and it's just basically how you do things now. You really need to think about how stuff is going to sit on disk to minimize the latency of getting that data off disk, because once we get to scale and network partitions, issues that can crop up in a distributed environment, is that you really need to kind of take all these things into consideration. And that's going to start with your data. So, that's a topic to itself. There's a number of good presentations out there. Anything by Apache Cassandra, University of DataStax, some of the models, done some really good presentations the past 18 months, 2 years. There's a good one earlier today. Do some research. It's really hard. It's not, if you're coming from a relational database world, it's different, and you really need to sit down and think about that. And it's all for my day-to-day, it's the #1 performance problem that we always see. It always comes back to data model. Almost always. The last thing that you want to do is try to port your schema to Cassandra. This is not going to work. There's the other point I'll add in here is the takeaways that there's very few reasons, causes, and needs to use of built-in secondary methods. They're just extremely dangerous from the concept of scatter-gather across big topology. It's really easy to shoot yourself in the foot. It's something that you probably want to maintain by hand. But that said, data modeling and using CQL, query language on top of there, it's got some really good tool support built in now. The trace discovery is really easy, and it's a great documentation. It's actually maintained in source tree, which is sort of unusual. Some documentation sort of stays in step with the project. DataStax makes a really good tool called DevCenter. Now, a good example, 2-minute videos, a quick watch up on the website about what you can do with it. It's really quick. It's what do you expect from like a WYSIWYG together? It's inline, highlighting. You have a little squiggle up top because I have to create up there, and I didn't create if none exists. So real-time validate what you're typing. Figuring out that type of thing is really easy to use. You can also see on the bottom query tracing window is a really good presentation of query tracing. So that gets us into the writing code section. And again, it's been all day about it, but writing code is a beast into itself. There's other things to consider. First of that is that this has been tried a number of times over the years. I've tried it twice myself. It's already a big enough impedance mismatch for the database. Maybe consider an ORM. There's a decent one built into the Java driver that is okay, but I would only recommend if you're going to do a simple CRUD operations. You should not use them generally for queries. If you're coming from like the perspective of hibernate, just don't. Like it's hard enough with a relational database, it's gonna not work at all with a column data store like this. Use SQL, become familiar with it. Use a Java driver, excellent piece of software. It's got dedicated resources on it. We'll go to some of that. Really good test coverage. I use this throughout my presentations, like going to some examples with the driver itself, like how things are done and how you might want to consider doing stuff on your own project. It's open source, so you take it apart, see what's going on. It's an excellent example of like how to deal with netting, channels, pipelines, and factories. If you're doing anything else with netting, it's a good resource to look at. And DataStax, just from the commit messages I've seen in the past 3 months particularly, it looks like there's about 3 or 4 people who are dedicated on that project, which is a lot for driver projects. So if you use Spring, Spring Framework has a Spring data integration with the Java driver now. It works really well out of the box. Juice, there's a project out there called Juicy Fix, which uses Netflix's Archaeus, which is like dynamic runtime configuration with Juice. Something to look at if you're using Juice in your software. First of the rules for writing code for the driver. This is like the first link. If you look at DataStax documentation, they cover this in detail. But 1 cluster object for each physical cluster, 1 session per app per keyspace. Prepare statements if you're going to execute more than once. Otherwise, you're going to burn a lot of network I/O. And use batches to reduce network I/O, not necessarily for efficiency's sake. Asynchronous operations, as inserts and prepared statements directly on the driver, are fast and the coordinate concatenation into the same partition, depending on our structure. Configuration itself is similar to other database drivers with some caveats that document in detail, but the main difference is that it's a cluster. So you're not just dealing with a single master or single master slave setup. Really, there's 2 different groupings. There's policies and connections, and the policies have to do with like load balancing, what kind of load balancing algorithm you want to use, what type of connection mechanics you want to set up, and compression, and like what the retry logic. Connection options specifically are protocol, level, like Nagel's algorithm, that type of socket setup, pulling, and socket structure. And another note with dealing with the Java drivers to really sort of get your head around asynchronous, writing asynchronous code if you haven't already. I highly recommend becoming comfortable with RxJava or dealing with the way that that's reactivity is dealt with in Java 8, if you want to look at that. There's a good section in the driver having to deal with user-defined types. It's an interesting thing where you can actually say this row is specifically this type of object, but I'm not going to go into that too much because under the hood there's serialized laws, which is like a really bad idea. You want to update one field, you update them all. New version's already being discussed there for 3.0, but it's going to be a painful migration back. I'll say wait, just hold off on that. The Java driver has metrics built into it, the metrics API. There's a lot of good useful information coming out of that. You definitely want to use that in your own code, so you're going to have it there anyway. And I'm just going to go into this somewhat a little bit later, but you can never have enough telemetry out there on for in your infrastructure for logging, alerting, anything along those lines. Turn it. I don't like it, you don't like it. Still, let's look at that. There. Is that better? So metrics. Using metrics API for your own code and making sure you have a lot of intelligence. I can't tell you the number of times that I've come in to consult for something, and I ask people what their disk I/O is, or their storage capacity is, and they don't know. You need to know these things when you put a distributed system in production. You need to have There's a sort of intelligence across your architecture about what CPU usage is and what logging infrastructure is doing, so you can sort of coordinate these things together when you're trying to hunt down a problem. Because you distribute the system, the more data you have, the easier it is going to be tracking things down, and particularly in aggregate. And building up historicals on this will tell you, oh, when we released that new version 2 weeks ago, all of a sudden our storage requirements went up 20%. The feedback and capacity planning, which is just how you care and feed in a big system of production. It's just as data volumes grow, your systems get bigger, you're deploying more hardware, it's just you need to have a handle on this stuff. So start now, put in your own code, get it all integrated. When Riemann Riemann is an excellent product. It's open source. It's just a real-time streaming API. It's really lightweight. It's 3,000 lines of code or something like that. It's totally horrible JavaScript. But you have dashboards like this that you just run on your local laptop, monitoring what you're doing in development. Just really straightforward latency. Does anybody do anything like this? Like try to run monitoring on your systems when you're doing development?
You're an Ops Center.
Ops Center good. That's pretty lightweight. Not quite as lightweight as Riemann, but lightweight enough. That's another good thing to have in the background there. Because once you get comfortable looking at this from a development perspective, it becomes that much easier to chase these things down in production. And I can't say that enough that becoming comfortable with the tools and how the monitoring is feed into them. The log file messages are just you need to know how to do it, particularly as things become distributed, and you just sort of hunt down these problems and they can be manifest across more than one machine. Actually, I have a demo of this I can show later if anybody wants to grab it all. I almost always have something running on my laptop, like I have a 3-node Vagrant cluster running right now, and I have the Riemann image next to it. If anyone wants to see that, I can show you after the thing or after the presentation. Tracing facilities are built into the driver and built in Cassandra. So do that frequently. That's really super easy to do. Is you can do tracing via the DevCenter. You can tab on the bottom for every query you run, where you can see tracing output with the request data, trace per query in SQL shell. And this is also an invaluable tool because it helps us track down problems to see kind of sort of precisely what's going on. Let's walk through a demo here. So on SQL shell, it's simple saying tracing on. And so we enable tracing for that session. This is an example I took out of production environment, permission of the client once it's been anonymized. But start tracing session, and we can see the actual output of the tracing session, statement preparing, queuing data request, blah, blah. This is all the network conversations going on by gossip and how the queries get broken down. And you start to see on coherent nodes how they actually are hunting the data on the disk and what's coming back. And interesting things like key cache hit rate, the number of tombstones, SS tables, where the node is actually looking for data on the disk. And you see this here, this is a timing column, and we go from 38,605 microseconds to 928 milliseconds, like almost a second. In that one thing there, and we go back and we look closer to that message, and we see red one line and 2,500 tombstones. So there's a problem. It's really clear that this data model needs help, and this particular row is an outlier that had a number of edge cases with it, and so figuring out a way to get rid of it, the volume on the system. So the tracing just becomes extremely valuable in this because you can kind of try these queries out, see if you can look at your production on your lab data set, and you can find the problems before they come around the bike. You can enable tracing in the driver. Documentations there on the slides. It's pretty easy. It's just a simple set method where you're setting up the options. Note to use set trace probability. If you want to say I want to trace 1 out of every n requests, you can do that too, at random. Then make sure you do all the game with the node down, because that's going to be the most interesting output, is what's going on, to make sure that in a failure situation that you're doing what your cluster is doing what things. final note on that is do it sparingly, because the results are written to the table on disk. So every time you run a trace, you're writing a bunch of columns in a row somewhere into the system schema. And it's being persisted on disk, so the trace, oh, etc. So you kind of quickly shoot yourself. Interestingly, coming soon, it's been worked on the past couple of weeks. There's been a bunch of commits on client side, it's a little really long. It's long overdue, in my opinion. Sort of a neat approach to that. It just starts spitting out queries that take longer than X from the Java driver itself. It's a good approach to that. Another good thing now is that login verbosity can be changed dynamically in Cassandra. It hasn't been able to do that since version 4. Ready to particularly. You can do this by GMX. You can do this by touching the log file itself, and it'll get reloaded in 10 seconds. I think it can be called. There's also in 2.1, there's a no tool set login level you can use now. So you set login level by no tool, which is handy. And speaking of which, no tool for developers, we can call this sort of the holy trinity no tool here. So cfstats, cfhistograms, and proxyhistograms. Cfstats pertains to statistics about size and performance. It's the single most useful command. If you know nothing else, know this. You need to know two things, know cfhistograms as well, because that'll give you common partition count and the size versus latency histogram distribution. So that means that I can see that the majority of my reads are being satisfied in the first 2 SS tables, or unfortunately, the majority of my reads are being satisfied in the first 50 SS tables. You see this when you examine the output. There's a lot of documentation out there about how it works and how it looks. You definitely can play with it. You're not going to break anything. It's strictly the reporting mechanism on memory data, so it's easy to work with. Proxy histograms is sort of the same thing, but for inter-cluster communication. So you can see how long the request took between coordination from one node to another. And just between those 3 no tool options, those are going to be by far the most valuable thing to know. And you just have to know to be able to diagnose things as you're doing development. Managing environments. So this is always an interesting one. Is configuration management is absolutely essential in the cluster. If you have somebody like an operations person who's an operations team who's going to log on and change some stuff, like you're doing it wrong. And so the modern day, with the maturity of the tools that we have now for managing configuration, it's essential that we're using something like Chef or Ansible or Puppet to be able to push changes out across architecture and track those changes, what the effects that they have on the system. Ideally, you take your code from laptop to production with no minimum modifications. You should be able to do that. The tools are out there, they're open source. That's one of the things you have to do to make your environment more efficient and just more understandable. More of that to be troubleshooting. That gets us into sort of how number of ways we can run Cassandra in development. I have a couple of options listed here, and the first one, and unfortunately I see this a lot, is that if you use a system like Cassandra and you're using like a shared instance somewhere or like a shared cluster, basically, if you do this with like any resource where there's a development server in the other room and everyone's using that, like, you're doing it wrong. Because there's no cause for doing that for an open source project where there's no person cost for development. That makes things unreproducible. It makes it ways on how the system is managed opaque to developers. And it's not a good process. Just don't do it. Stop running out of effort, like MySQL or whatever. Unless it's a licensing cost issue. There's just no reason to work. So running Cassandra locally, like just download jar, you can do this. This is pretty straightforward. It's easy to set up. You control it. And the downside is you control it. You change something, you forget to tell the rest of the team, you forget to put it in whatever, and it doesn't get pushed out. There, and you can run a situation, well, work on my local machine. And that can be, it's just easy enough to avoid that, but you probably shouldn't go that route. Much better is using something like CCM, which is a Python wrapper around the Cassandra jars itself. It'll actually download the Cassandra manage download process for you, so you can specify versions, run some, have multiple versions downloaded on your machine, and choose between them. You can set up clusters of data centers on your local laptop, just by forking Java processes. You can take individual nodes up and down, so you can see what happens. But this is a really useful tool. The distributed tests in the source tree are built around CCM, so it's used by DataStax directly. It's an open source project maintained by Sylvain, one of the developers. You can download it, hack on it, do whatever you want. I myself, I'm a big fan of Vagrant because isolated controllable environment, the way that multiple vector machines are set up, you can create private networks to have these things behave. CCM is great. It packs on like the logo host driver, so you have to go and reach for like 127 nodes or 127 nodes, 3 if you want to do stuff like that. Interface configurations. Or Vagrant can actually pretend to be on that. And pretend to be in some little private network setting. It does have that as you can, configuration management integration. You use Chef, use a Chef provisioner, and lo and behold, you're testing your configuration management at the same time you're testing your code. I guess like everyone calls that DevOps now. That's just kind of solid process. And use the same configuration manager for production. Knowledge. But like it's doable. You can do it, and it's not hard to do. This is an example Vagrant file that I sort of have in my back pocket. I can show you guys this. I'm going to put this up on GitHub actually, so more people start doing this. Here I just have a defined up at the top. I have a server count, network, refer to that IP address. So I say my first node is going to be 192.168.2.10. We go down there and in the loop, this is just Ruby, which is a Vagrant configuration mechanism. I say that do some Ruby syntactical sugar to like tack on 10, 11, 12 to the back half of the back end IP address. Calculate the tokens I'm going to use for Cassandra, then drop those into the listen address. And this is just a configuration that gets pumped into the Cassandra document. So you can see that this configuration here. Actually, I spent a lot of time with this. This is actually a really good configuration for micro Cassandra stuff. If you ever want to know what you want when you need to turn down, get everything working, throw it on a load box. This is Cassandra running environment for all things in memory. So this is hard one, these settings on what to do, but this is a good way to like run. I've run it to plus 6 of plus on my laptop, 2 data centers, for testing, verification. It can be done. You're doing performance of work with machines running on top of it. That's what gets us into testing. Testing, particularly from locally all the way up, pushing up to Jenkins, or Travis CI, whatever you want to use. Use a naming scheme because unit tests and integration tests and parallelizable integration tests, right? The more you break these things up and the more you can sort of separate them out, the better off you'll be in terms of like developer productivity. There's like papers on some number of wasted hours, just like person hours. So that's sort of the reality of stuff. There's like this fantastic amount of wasted hours of people waiting for a test to run, like code to compile, stupid things like that. There's just like, 1 minute, 30 seconds every time I want to go through something. It's just like that's not the way to do things. Unit tests that don't have any external resources. Should code like unit test. If you use external resources, it's an integration test. You do it in parallel safely. You can parallelize it. Get a different name and give you some fancy magic with naming or Gradle, whatever you want to do as possible. Wildcards on CLI are not means. It's like MPN test, star, whatever. That's okay. Using actual grouping annotations, both a JUnit and TestMG is a really good way to break things into suites to get that run for segmentation, get better performance, and make developers more productive. You can share test data. It's really straightforward. Like you can have the same sort of suite set up a set of test data explicitly to test for the user account data because it goes through the user account. And just use that data when that small suite is done, provide that data, and somebody else will come and testing of the component of your system. Jenkins, they've been built in the Jenkins and testing G for years now. Definitely explore and look at those. The driver actually has an excellent example of this. They have profiles. There's a good use of name profiles. It's a short, which denotes I'm going to run everything that's in a short unit as annotated in source code. And as you can see, is test groups for short. And so when you run the short profile, you only run these things that are going to do like a real simple selects and run a real simple infrastructure. They're just going to run the test as well as it's taken. Both J and test and G have the same sort of concept of like before and after speed, before and after the group, using test listeners. These are all really good ways to set up data, to group things into sort of repeatable units. So there's no waiting around for databases to drop or whatever. That said, use mocks wherever possible. This is just good practice. Maybe more so when you don't necessarily need to test the functionality of the driver itself. Integration tests. Again, so who here actually knows the difference between a named and surefire plugin and a named and fail-safe plugin? It's always like 2 or 3 people. And it's not clear, right? Like you have to go read it. And you have to the pages even look the same. There's like words have been found and replaced on both those projects. What? I'm not going to get them right. The surefire is for integration testing, fail-safe is for unit testing. They can do different things. When you trick them out right, profiles and annotations, it makes it really easy to sort of control how long a test is going to take. So the one thing you just broke, you don't have to test 10 other things, which is no side effects. In general, testing on a distributed system is you want to test your failure scenarios of simplicity. What happens when I try to read a quorum and there's not a quorum in the nodes? It doesn't matter what the replication factor is necessarily, is that you want to know what your application behaves like and what those exceptions look like when they come back. I don't think I had it on here directly, but an excellent way to shoot yourself in the foot, and it's unfortunately very easy to do. The number of clients and driver libraries out there is an automatic retry. Don't do that. Avoid that. You want to catch that explicitly in your application code and do something based on the business requirements of that process. Because if you automatic retry, it would seem like a good idea to do that. We'll take a cluster to its needs stack and if it's in that condition. It's not something we do. We put an actor very early on, and I think a lot of people just pick that up as a pattern, and it's one of those things I wish I could have taken out after the fact, because it's a bad idea. I'm responsible for hacking, by the way. Anybody remembers that? Runtime integrations. So we've talked about them already, but just conceptually, there's 3 different types: local, in-process, or fork process. Embedded Cassandra is kind of interesting. There's a project out there called Cassandra Unit that does this. This just basically launches it in memory Cassandra, and it's really easy to test basic stuff. It's a good idea. It's like kind of dip your toe in the water. The guy who writes it, he's been a long time contributor to the community from like the application side, driver side stuff. And there's really sort of super handy, easy to use loading mechanisms like CSV loading and CQL loading, where you can throw some data down really quickly, have a consistent set of data, pull it up and tear it down pretty quickly. Next are approaches like process building or forking from Maven. There's I've worked briefly with Stephen Conlon, who's at CloudBees. There's a Maven plugin to do Cassandra forking. If you have the time to keep it up, it's actually out there if you want to see how that works. Using home screens and managing processes directly. Like sort of what CCM is doing, but like not together. Within the driver itself, and this still isn't something that you can get to directly because it's not available on the driver. CCMBridge is a class that's in the driver that actually put on the bottom of the slide there. Definitely worth taking a look at because that's in process sort of forking from a test infrastructure to CCM to actually interface and say, I want to create a 3-node cluster for this setup, go. And CCM manages the cluster setup and distribution and everything within the context of the test. So if you're pointing at something like Jenkins, as long as you have an icon installed, that's an excellent way to isolate that. So that's a really good tool to have. And unfortunately, it's something that it's not available on the jar because it's not put in there as part of the testing classes. You kind of have to gut it out, but it's standalone. Actually, I have a version of that going out. I can show you the technical objects that go out there. There's no sort of intertwined dependencies. You just state your project as it is and throw a distribution on it and set license. So, again, I really like Vagrant. And it'd be just as easy to sort of do the same sort of delegation process forking to the Vagrant CLI to do that. Either way, using Jenkins or Travis CI to manage your cluster that way. Makes it so things can run parallel. They can be their own isolated environments. So multiple things going through the test queue, which is ideal. And the difference between the two is really just a matter of choice. And integration with CM. I really like the idea of Vagrant and potentially Docker as well as the configuration stuff is straight up in Docker. It's not quite clear to me the direction that's going to go. It seems like it changes every month. I'll let them kind of fight that fire before it gets to the point. This is why I don't put it here. I think it's compelling technology, but it's still, until somebody can give me a straight story on how the distributed configuration of Docker is going to work, I'll focus on those things. So the best part about something like Vagrant, where you can pump in your configuration environment, is that you're continuously testing your configuration management along with your developers. And that's just like, I don't know why you would want to do that if you have those things you want to take a shot. And also, this is like a matter of what else is in your architecture. I do Python stuff, I'm doing sort of other things that require coordination methods. Load testing. It's definitely something you want to get into, is to be able to build reproducible metrics, capturing progressions, and see what happens when things break, or when things get to a breaking point. All these systems have different failure characteristics. You'll be able to find that is what you want to do. And again, what I like about running these clusters locally either by CCM or Vagrant is that something that's underpowered and something under duress behave very similarly. So throwing these really small configurations at these things and just pounding like you can from a laptop actually gives you meaningful data, because that's what's going to behave like when your big hardware on production starts to have problems. Because they're almost identical. In terms of where the things start to break down. And Cassandra Stress for 2.1 has a lot of changes. There's 2 really good articles on that page about how to really, you can now configure it as normal, make sure the test run, and work out read write balance. And it's actually the distress tool, which has been years ago. You can incredibly powerful things right now, sending your own specific workload at it. So it's just something to definitely get put in your arsenal and start using it now, just to test stuff and work with it, see what happens. Because testing actual runtime data is just like the panacea of software development, because it's extremely difficult to do. Take a workload, a production workload, and try to test. I actually have a whole presentation on submitting later this summer on this, but when sort of the emerging patterns out there that we work with a lot of clients on is that taking stuff from your key architecture like Kafka and simultaneously replaying that, capturing Kafka capture all the rights and replaying that into your test cluster to build the data on top of coordinating backups from the snapshot. So you can launch these test clusters, go on the production data, run the play the Kafka keys, bring them back up to the current point in time, and then just test tag out with whatever you want. Even viewing production data, there's a few layers, whatever. It can be a really powerful way to sort of test changes or try out new ideas. topic into itself. We haven't talked about that afterwards. Workload reporting, pull back. I'm sort of disappointed in the issue. Detailing this explicitly, and sort of got punted on for 3.0. And it's actually moved to a different issue there on the bottom. If you're interested in this, it's totally doable, i.e. for capturing slow queries at the Java driver level and have captured all the queries and fork them to the log file. That was kind of easy. So with anything that's open source, the more attention issues get, the more people vote on them, the more people click on them, those are the ones that are work on. Ancient beast, submit a patch. It sounds like something's interesting. These types of sort of outside-in issues are an excellent way to learn about the system. Interesting in internals. In general, the primary testing goal to have in the show is that don't let the cluster behaviors crush. You really want to understand what the failure characteristics are, what the performance characteristics are, and build up as many sort of actionable metric items as you can out there for your system. And have people familiar with them so that everyone knows what it looks like when stuff starts to work. And summary is just go slowly in bite-sized chunks, segment your tests, monitor an instrument, reference drivers, use DataStax driver if you can, control your environments, and just verify any assumptions about build. And it's the last set of slides I have. Go.
Just a question.